Okay, so welcome everyone to our third meeting. We have some interesting questions we're going to discuss today, and as usual, there'll be three groups of questions, and we'll go one by one, and we'll see how far we can get. There's no guarantee that we'll get through all of them. So the first group of questions will be about physical learning. That's something I'm actively working on, and so I can tell you about this. And again, I want to hear lots of feedback from you, what you think, what's possible, what's not. The second type of questions will be about diseases and aging, something that I haven't worked on, but something that the theory of learning tells us, gives us a unique view on that, and so we can discuss that. And the third one, the philosophical implications, again, all bets are off. We'll just try to, we'll do our best trying to understand what the philosophical implications are. So let's get started. First is physical learning. And the first question is, can we build an artificial neural computer? And then the follow-up question is, can we build an artificial quantum computer? So my take on this, that we will never know until we try. First of all, what is it? What is an artificial neural computer? It is an attempt to actually take the learning dynamics of artificial neural network and put them at the level of hardware. Whether this is possible in principle is a great question. How much you want to put on the hardware is a question. What would be your approach is a question. What is the right material? There is a bunch of questions that needs to be answered. I think if everything is learning, if everything is a neural network, then it should be possible. Now, what is the right material is a challenge to find. So we are working, trying to identify that. Now, of course, we do have a good example, biological example of a neural computer. It's ourselves, but there are a lot of other challenges that are on our way when we're trying to actually create a condensed matter or soft matter material for that. But an interesting twist to this, and I like it, but I don't know if it will fly, is that once we make it, it may turn out to be effectively quantum. Now, then you must have heard all about this noise about different companies trying to develop a quantum computer, and all the serious people will tell you that not going to happen anytime soon, but it doesn't matter. People are still trying. There are actually technological problems of doing that. But if it is true that neural networks effectively give you effective quantums, not the true quantums, but the effective, then we may trick this obstacle and actually create just a neural computer. All it does is learning, but effectively, in certain limits, it actually performs quantum computations. Not all possible quantum computations. It's not going to be a universal quantum computer, but some type. And so that's kind of the hope and the idea. And so if somebody has any thoughts about anything that has to do with computers, go ahead.
I just have a question to make sure I understand correctly. So with an artificial neurocomputer, what you're basically hypothesizing, and I think even your research has shown this, is that you don't get enough degrees of freedom by just trying to do the neural architecture in software. You actually need hardware to fully bring to life, basically to offer the complexity and the degrees of freedom required. Is that correct?
Right. So degrees of freedom is a good question. Scaling, right? So digital computers were not made for learning. That's not what they were made for. They're pretty good in like adding, subtracting, multiplying numbers, but that's not how they operate. Now, and we don't want, to do learning, you don't need all that. All that you have to do is to be able to create these two types of degrees of freedom, trainable and untrainable. And the more of those degrees of freedom you have, the better your system learns. There are questions, why is that the case? What's really happened underneath of it? And that's all separate. But we've seen ChatGPT, right? They created a huge computer with lots of degrees of freedom. It works. Well, I mean, it works to a certain extent. It's still a pretty stupid system, right? So, and actually our little experiment of people posting questions on different subjects and then ChatGPT posting questions showed me that that is not even close, right? So people's questions are much more in depth, and they're like working on a whole different level. But yeah, the straightforward answer is yes, we just need more degrees of freedom. more degrees of freedom. And then if you can really have like bits, right? Only in neural dynamics, it's not the bits, they're not discrete. They actually have to be continuous variables. And that's another thing, you created digital computers, by construction, you made degrees of freedom discrete because you want them to be stable. You don't want the memory to, be easily erasable. Now, for learning dynamics, it doesn't matter. I mean, it's you move your weight a little bit to the left, a little bit to the right. Network is not that much sensible to this. Certain, of course, directions are prohibited, and then you don't want to go. But there is a lot of this flat direction. Revel, go ahead. You had a question.
So, as far as what's been done in the past in the last few years, has anybody's created the 2-qubit or the 4-qubit or whatever they call it, quantum machine, and what does it accomplish?
Yeah, so the 2 qubits, a few qubits, 10 qubits, that was like already done a long time ago, right? Scaling is the problem. Creating a system that has more and more qubits, and then trying to actually make this system universal, right? So you want to be able to apply arbitrary operators to the state of the few qubit systems. Now, one way of understanding of why quantum computers are so good, it's really the state space of a quantum system grows exponentially with the number of bits. And so that's kind of like, you say I put 10 qubits. Well, it sounds like nothing, like 10 bits, but the state space where you can put the system is exponentially larger than a classical analog, because you can create all possible superpositions. Like, okay, that's the fancy word, but of different classical states. Now, another way of, since we're talking about quantum computers, another way of imagining why quantum computers are so good, think about having not a single classical computer, but many classical computers, and they all operate in what people call parallel universes, right? And that's what actually happens. It's like a good way of thinking why they're so productive. Is because there are many of them, and then they operate one in each universe. And then the challenge is actually extract useful information from all those parallel computers. And in the quantum systems, you make use of it. But there are two obstacles to quantum computers. First is actually creating a state that remains a state and doesn't decohere and doesn't interact with environment right away. And because once it does that, it is no longer a pure quantum state. And so that's one problem, creating a state, really legitimate quantum state, large but quantum state. And the second is to evolve it, because evolving is like computing. And for that, you need to create kind of Hamiltonian or gates, quantum gates that will take it. And so both of those problems are hard to accomplish. For the first one, I already said, because there is always environment, and for the second one, there is a lot of the space of possible operators is very large, and so you cannot really recreate all operators. And so what you do that you decompose them in the small gates, small operations, and then but then at the end of the day, still both of those problems seem to be. Now, in artificial quantum computing, that wouldn't be much of a problem, because noise is what needed. It is always present there. In learning system, noise is always there. We use stochastic gradient descent, so it's not gradient descent, stochastic, meaning that there are few directions that you can go, and all of them are pretty okay. Not perfect. You never get to the true learning equilibrium, but that's fun. And so there, kind of noise is put under the rug, or maybe noise is what gives you effective quantumness. But again, I have to also pause and say, you do not necessarily, it's not an equivalence. You do not say that you have a learning system that necessarily quantum. No. You have to adjust your learning algorithm in a certain way so that happens. And whether you can really recreate such an algorithm and such an architecture with a physical hardware that is learning, it's a big question. So we're not even possible. Hypothetically, it would be interesting that you create a quantum computer from basically a classical computer, but not digital. Definitely not digital. So other questions, comments?
Definitely not digital, you said.
Say it again.
Did you say not digital?
Not digital, right? So I mean, it's more. This is the thing that is very important for neural network to be able to learn. You have to be able to take derivatives. Basically, you have to of the loss function, and then you have to continuously vary your parameters. Now, of course, in digital computer, nothing is continuous. There's always that precision, but nonetheless, that's what you want. Ideally, you really need analog computer, which will be a horrible computer for Zoom chatting. This will not do that, but that's not what that computer should do. It should just have those two types of degrees of freedom. Think about this: that the classical computer, it just has one type of degrees of freedom. It doesn't have this adjustable, learnable, trainable degrees of freedom at all. Just not there. It was not designed that way. Okay, other questions? Yeah, we can talk a lot about computers. Anatoly, go ahead.
And do you know about this brain project? About organoid type computers?
Oh, do weigh computers?
Dish brain.
Okay.
Тарелка мозг.
Okay,
And,
tell us about it. I don't know.
Oh,
Mm-hmm.
very interesting. They grow about 100 of millions neurons of mouse and humans, and work both. And after this is a small neural network, and all your quantumness is there. And after this, how they can learn this, because no input, no output. They have electrode substrate, and they simply input this into Pong game. Do you know this Pong game? And after this, if Pong signal missed, they put noise to this electrode matrix to greater difficult to say into English.
Well, you're doing great.
Yes, and they have noise to the input, and this is more surprises. And after this, after 5 minutes of such a training, this neural computer have played Pong. They teach it without all this reinforcement learning and other learning processes. Simply,
so this is a biological network, right?
Yeah, simply a bunch of neurons. And this is, according to theory, effective inference. It should it should fit to minimal free energy principle. And to have no surprises, it has noise. It should play Pong, and it play Pong after 5 minutes.
Yeah, I saw that. I think I know, now I know what you mean, right? So this is biological.
Yeah, but after this, they have a paper, then that you can grow a big brain clients like structure, and this is organoid. They check organoid like brain, but not organ, but organoid, something similar to organ. And after this will compute. And this is energy effective. This is technology already exists, and we know how to put it in learn mode. And
how do you feel? How do you feel
huge, about 1,000 of kilograms of brain, and this is huge energy effective quantum computer. And why not? They have a paper on it.
Okay, so first of all, I think this is a biological neural computer. Now, it's not going to be quantum for sure, because quantum.
And what you mean about quantum? Because quantum like mathematics underrated. or a
No, 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 no.
quantumness, true quantumness of
Not true.
small subatomic particles.
Yeah. So let me explain. So like first of all, it's biological, right? So this is, you have to really grow this brain somehow. You have to feed it. You have to you have to supply it with a living material. But this one is not going to have true quantumness for sure. So it's not going to have, it wouldn't use the fundamental quantumness, despite of the fact what Penrose claims that. But it will probably not even going to have an effective emergent quantumness, because for that you really need to adjust your learning dynamics in such a way where the neurons come in and out of existence, and so that's kind of essential part for learning. But that's interesting, yeah. So the biological computer is yet another direction that one should investigate. So it's not an artificial, but a biological neural computer would probably be something fun to investigate. Okay, let's move on then. So next question, well, it's related, right? How can we develop systems that can process and learn large amounts of data? But that's the whole point, right? Can you scale it? With the quantum computers, you cannot scale it. Now, if you have a material that learns, I can imagine it can scale. We just take a bigger chunk of material, take many chunks of learning material if you can do it. Now, if it's a truly biological learning material, and then actually it can grow and you supply it with, you feed it somehow, then it's interesting to understand its capacities of learning. Certainly, this is a direction that worth investigating. I agree completely.
This is not biological completely. To me, the cell, biological cell, it's a material, and after this is engineering.
No, I understand, but it uses.
You have a task to grow one, for example, half a ton of brain, and this is engineering task.
Yeah, after that, it's
have electrode matrix, and I will be fetch work of Vitaly Vanchurin that tell that in all this brain there is some quantumness inside, because this is neural network.
That's right.
And this will be this engineering task, and I wonder why you insist that this is biological. This is another, and I will have next step some kind simplified cell. According to Alan Kay, that tell that programmers should see the nature, because cell is very complex, and small brick of material science should be very complex. And then I will have not 3 atoms as a quantum cell, but some kind of biological cell, very complex. But it will be quantumness inside this neural structure.
Yeah, I think that calling it biological computer is just the matter of language, right? We already discussed it last time that, where do you put a boundary, biology and physics? Yeah, if you, I would say, boundary. Yeah, there's no boundary, right?
Engineering.
Yeah. But I think the point is that if you use it starting from a biological large cells consist of many molecules, then you're already in the regime that is kind of much more complex to monitor and to model than a collection of molecules that already have capability of learning. So like let's rewind ourselves to the first meeting when we discussed the origin of life phase transition, right? We have already molecules that are long enough, that are complex, and all of a sudden the phase transition takes place and they start to replicate and they start to do other things. So I agree with you that we should not put the boundary physics biology, but what's the starting point? Do you start with the complicated stuff like biological cell and then you make it simpler and simpler, or you start with simple things like molecules and make them more and more complex so they resemble them. Then we
For
may just-
example, proteins. This is molecule.
Exactly. That's my point.
I simply tell you that you should not regard water molecules or small molecules.
No,
That
no.
this is quantum computer. No, it should be very complex and huge in atomic scale.
Mhm.
Protein complexes. And Alan Kay tells it that in software engineering, we have two simple systems to engineer it. And this is very hard to scale. And if you want something to scale, you should have something complex like biological cell.
Right.
And after this, you can have organism with trillions and trillions of cells. But cells is very complex itself.
Right.
And I tell you about system levels. For example, if you have computers from NVIDIA, you have the gate level and process of the gate, the chip level with about 15 billions of these gates on transistors. And after this, you have circuits. After this, you have crate. After this, you have supercomputer, and about a dozen of distinctive levels they have to simply have computer. And
Yeah.
when you speak about this network, you speak some kind not in deep paradigm, but in shallow paradigm. You have only this quantum level, quantum network. No.
Yeah. So I don't think so. So let me just put some requirements for the computer. Yeah. So let me put some requirements for the computer that must be necessary in order for it to be called the artificial neural computer. Now, it needs to have percolation. So information has to go from one side to one side. And so in the language of cells, cells should be able to actually communicate from one side to the other side of whatever your quantum computer is. So percolation, one. The second one, plasticity. Has to be able to reconnect and form new bonds, new bonds or new synapses should be able to grow, like, whatever language we use. And that puts another constraint on the material, whether you call it biological, physical, but that's not all. So now I'm coming to your levels constraint. That's called criticality. So the system has to be at a critical state such there are structures, and there's structures of structures, structures of structures of structures, and we do know exactly what such thing happens in physics when the criticality is formed. And the fourth, and all those three are essential. And then the fourth one is the follow-up. It actually follows, often follows, it not necessarily follows from the third, but you need to have a Glasses system. And a Glasses system in physics means the system that can be in many metastable states. So it's possible for system to be stuck. There's not one minima, but lots of different configurations. And so digital computers score pretty high on many of those, but not at all. So they don't have this criticality structures. They don't have, but the brains have everything. All those
brains
are described.
And organoid computer. Call it organoid computing.
Right, exactly. So
they
it's
have
probably something close to both in between. Yeah, Revel, you kept raising your hand. And I
just had this notion. You were talking about what materials are we going to do for this, and I had this idea. I noticed this a long time ago, maybe when I was a kid, that carbon was or silicon was right above carbon in the periodic table, and I thought, well, here's us, and here's what machines are made of. So maybe there might be some carryover between that. This looking upwards at
Right. So I wish it was so simple as just choosing a simple material. It most likely will be a combination of many materials. And so, I mean, I cannot disclose you all of the results that we have now, but it will be a bit more complex, just picking one element from the table, although it's a great table.
Isn't it? Or is it?
Yeah, no, but you're right. I mean, that this is where, and Anatoly is also right. We can like approach it from both directions, from biology and trying just to simplify cells to the bare minima so that they keep doing what what we want them to do, or from the physics side, trying to complicate molecular structure more and more so that it has all those features I described. Yeah.
What were those people that did the xenobots, those self-reproducing half hybrid things? Remember that?
It must have been Levin group. Yeah.
Maybe. But they had this thing where they had taken these frog cells and they had made them.
Yep.
into this-
Yeah. I think it's Levin group from Tufts University. Okay. Cool discussions. Very interesting. So yeah, we will come back to all this later. But we already answered 2 questions. So how to develop a large one? We really need to figure out what the fundamental building blocks, and then we should have it scale and things. Now, but then the next question is, I don't know who asked that, but can we use physical learning to create intelligent machines that can think and learn like humans? All right, so now everybody is afraid of ChatGPT. Everybody is, some people are afraid. Some people just let's use it.
Why we need it?
Why we need it, right? Well,
we already have natural
super
intelligence of humans, and we need some kind of another type of intelligence to have another type of problem solved.
All right, so I agree with Anatoly. Forget about humans; they're useless. Let's just create a better intelligence.
Yeah.
Yeah. No, I'm all for it.
Not better. There is no free lunch theorem that tells that this is all algorithms, and there is no good algorithms that good for all type of problems. And this is if you have different problems, you always will have need for another type of intelligence, another type of algorithms to have efficient algorithm for particular problem. After
conjecture from Anatoly.
Human, then you will have your computer, and after this you will have about 100 first queue of different computers to touch first 100 of different problems, and this is theory result.
Okay, so Anatoly's conjecture that the space of intelligence is not continuous, discrete, very discrete. So they're isolated islands of different types of intelligence, and there are valleys of no intelligence in between. No. Okay, I'm just trying to.
This is a space, and where I point you to different places in space.
Yeah.
I'm not speaking about something in between.
No, I know. That's what I'm saying.
You will be not knowing about some kind of this multidimensional space. But after some time, you will be find new task, and all known computer types will be not effective. And now we have standard computer and quantum computer, simply. But maybe we'll have some kind of another types. For example, general type of optical computing on the diffraction, not quantum.
But I think what I'm saying is exactly that. What you are saying is exactly that. Now, all those computers can be modeled as some, cellular automata, whatever you want to call it, which has activation and learning dynamics. And then there is a space of all of the dynamics of all those computers, which can be described through the network architectures. And the subneural architectures will be doing one type of computing, the other will be doing other type of computing. So it is a space of all possible learning systems, or all possible computing systems. And your claim is the space is very discrete. So you go to one place which does one type of task very well, and that's isolated island there, and then there is another place where is another isolated island there, and in between maybe there is another new type of
not necessary, because this can be a spectrum from one point to another, some kind of path. And what about discreteness? I don't know, because you have
if there is
some
a
kind of
path,
computer evolve to efficiently compute some kind of problems, but you do not know type of problems before.
Okay, then I now understand what you're saying. I think you're just talking about different loss functions. So first I thought you were talking about different architectures. You're not.
No.
You're saying that there can be
I tell
different loss
about
functions.
effectiveness, not about loss function.
Yeah, effectiveness of
I speak
learning.
about effectiveness because you can all the computers is Turing equivalent.
Mhm.
They are universal computers with addition from Deutsch.
Exactly. And so
wish.
what is the ground to believe that they will give birth to different types of intelligences? Okay, different types of tasks, different types of computations, but
Victor,
if they give birth to some type of intelligence, it will be the same intelligence.
Not understandable, Victor.
No, Victor. If let me repeat what you said, and you will say that if it's correct. You're saying that there are different type of computational tasks that different computers can do, and so and we all kind of I think we agree with that. And then, but you can describe those tasks.
Not can do mathematically, but can do
but, sorry,
physically.
is it better? Is it better now?
It is. Go ahead.
Okay, so I just ask why we believe that these different types of computers will give birth to different types of intelligence. So probably they're different.
Yeah, exactly, and that's I think I agree with Victor. So it doesn't necessarily will give rise to different type of intelligence, but what may be different is for a specific learning task, they will have different learning efficiencies. That's all. And one computer, one architecture, forget about computer, one architecture, neural architecture would be good and efficient for learning one type of tasks for one type of training data set, and the other will be good for learning a different task for a different type of training data. So okay, I mean,
yes.
But I think we just jumped into the it was orthogonal to the question whether we can potentially recreate human-like intelligence, or maybe better, or maybe a different intelligence. And I think we're in the game where all that is possible. And even if we can all understand each other, we already as a group is a superhuman intelligence, because we all possess different skills and yet communicate together. So we are on a different level in the hierarchy. Okay, I think that was a great discussion of physical learning. Let's move on to diseases and aging. All right, something that I know little about. Nevertheless, the theory tells us a lot about it, and so we should try to pay attention to what the theory tells, and then figure out whether it is telling us something useful. So the first question was, what are the underlying causes of diseases, and how can we better prevent and treat them? So here I'd like to start with distinguishing two types of diseases. Diseases, if you got a bacteria or something from outside of your system, of you as a learning system, and that affected how you operate, right? It messed with your cells, messed with your neural structure. Now that's from outside, okay? Now COVID is a good example of that, right? It comes to us and we have hard time operating as we used to. But there is another type. Something can really break inside us. And so with Katya, we've had some exchange on the chat that cancer may be of that type, right? So where your own cells are just stop functioning as they should. And that's a different type of disease. And I will add to this one more, and that's kind of aging, is when actually, I think, and it's related to aging, but it's also related to overfeeding. When you have some part of the organism or whatever subsystem is, learn how to operate very well for a given set of conditions for a given environment. And then once environment changes, it is unable to adapt, right? So this inability to adapt to a changing environment. And we kind of discussed it, I think, last time in context of dinosaurs, right? So dinosaurs were pretty good, comfortable on the planet Earth. Everything was great. And then there was a sudden change in the environment and boom, all of a sudden, they are no longer capable of living in this environment, predicting its outcomes and learning it. So they were not very, they overfitted to the previous environment and they're no longer able to produce the new environment. So those are three types. Let me just summarize them. Something from the outside comes and harms given organism, whatever subsystem. The organism itself fails to operate. And the third one, when the organism is unable to readjust. Again, it's by organism, I don't necessarily mean multicellular organism. It can be individual cells or you know, on any level. Any thoughts on that?
Would it be correct to say that aging is, I mean, so basically the human body has overfit its cellular structure towards the first 30 years because it had no data to use you know, from year 30 to 100 for like the last until like 5 generations ago. There's no data that exists up there from an evolutionary perspective. Could you elaborate on that, or is that
That's exactly the point? I mean, your body is overfitted to what it learned in the first 30 years, and it remembers more of the more recent things and less of the, you know, things that you did in your youth. And you stop doing things that you do in the youth because it's not needed for your survival. You stop, you know, living active life and doing the other things we did as kids, right? But that's at a higher level. But it also can happen on every single level. You're just no longer you are learning very well of how to you know, be optimal at a given present time, but you have to put a cutoff of what you ignore. You know, how far back should I look? What I should I be optimizing my behavior from the knowledge of the 1 year past year, or from the knowledge of 1 hour, or from the knowledge of the entire life? You know, this is the choice you have to make. And overfeeding is when you just ignore all that what happened long ago, and you're just concentrating on the very recent small subset data set. I mean, we see it in the training data, right? So like for any machine learning task, you have large data set, and then it learns, then it becomes better and better learned. And then you show some other data set, which may be been generated from the same distribution, and then it performs horribly on this. Just because it just learned to look at the recent data and pay more attention to the recent data and less attention to the previous data. Now it's a wild conjecture that it's really overfitting. The body is overfitting. The cells are not able to adjust. They think they are really good, but they are not, right?
But it looks like your language here is misleading. For aging really stands apart in this picture, but it looks like aging, which is a disease at the organism level, is really some feature at a higher level, higher system level, at the level of population or whatever. And so probably you can fight disease which is at the organism level disease, but when you're fighting aging, which probably is a necessary feature at the higher level, you can run into very, very interesting consequences.
Okay. Yeah, it's a very good point. And whenever I say that something is overfitting or not overfitting, I'm fixing the level. Yes. So I'm looking at the level of organism and say, well, let's just forget everything else and let's optimize the organism. Like from the point of view of the organism, looks like you're overfitting. Now, Victor was absolutely right to say, well, but now let's look at the level of the population, right? Then what's the point of fixing you up? You're just a single neuron in this network of social network. And we do know that program death is actually a good idea. So maybe instead of like fixing aging for you from the point of social system, just kill that poor guy and give birth to another one. Absolutely true. I'm just viewing it from both sides.
You
fix the level and you
immediately
no one said
programmed DOS of all the books, for sure.
Say it again.
And you should immediately have burning books, for sure. Programmed
burning books.
Books.
Yeah.
I
Right,
write a book, and after 15 of years, it burned automatically.
Yes.
All the text disappear in a couple of years.
You wanted to add something to your
programmed DOS of all the knowledge.
I'm interested in, can you talk more about that third category of disease?
Yeah, the third one was the aging, right? So that's overfeeding. I mean, I call it aging.
Oh, I thought it was a system gets out of equilibrium and it can't get back. I thought that was your
right. So again, the situation with I think the second one you're referring to, when the system is well trained, right? So the cells do what they want to do. And then all of a sudden, they get into the wrong equilibrium. They just stop operating and doing what they were supposed to do. So there are like two nearby minima. At the level of the cell, we're talking about cancer cells that we discussed with Katya again online. It looks like it. So you have on some level, you have a cell or that is kind of been optimizing in collaboration with a higher level. Right, with the body, and then all of a sudden it changes its loss function and starts to say, well, I don't care about the organs, I'll just be optimizing myself. I mean, we see those cancer cells in societies, right? You have people who just stopped.
Yes, we do. We do. I wanted to, my brother has an autoimmune disorder, so this is kind of different from cancer. The body actively attacks itself. It's like somehow programmed. Can you talk about that? An autoimmune disorder?
So exactly. So now it starts to misinterpret the environment, right? And then within this environment, it doesn't react. Like for example, I have an allergy. Like I have seasonal allergies, like really bad ones. And what does it mean? It means that my body is misinterpreting the environment and trying to fight it as if it was the disease. Oh, there's too many.
Right.
So
how does it get confused like that? How does that happen?
Oh, because the optimization started to happen. Again, we just discussed those different levels. There's a level of organisms and the level of cells. So cell, it just forgot that it really is a part of the big body, and it has to really respect and optimize. There has to be frustrated, has to be balanced between two objectives, and it just concentrate on little things. And little things, it's not capable of doing more than distinguishing, all right, this is a bacteria, this is not bacteria. And it keeps doing that. Okay, bacteria, I fight it this way, non-bacteria, I don't fight it, or maybe I use it as a food, right? And it's and then if there is no feedback from the body to tell you, well, this is wrong, I can administer from the higher level how a given cell should operate. Then it starts to cooking up its own rules and algorithms of how to behave. Go ahead, Josh. You want to say?
I think it's really interesting what we're discussing right now. We're basically saying that there's a feature on one level could be a bug on another level. And not only that, it's probably necessary. Like the bugs that exist on one level are necessary often in some way to the dynamics of the higher level.
Yeah, so that's when Victor said that, it may be good for you to die and stop fighting aging, and then you are useless neuron.
No one said that it is not suboptimal. Probably it is really a suboptimal solution for the higher levels of systems. But we have to keep in mind that we have to check. Probably there is an optimal solution at this level, which doesn't have such direct consequences for
Okay,
our.
so I'll give a word to the next person who raised their hand, but let me just read the fifth question because we are answering it already. Should we
one
strive
more.
for human life longevity, or under which conditions that becomes good or bad? And so that's the answer, right? So it becomes bad to live long if it is in the conflict with the overall goal of the society to make this transition and to start operating and being more intelligent observer in the universe. So then you say, well, don't do that. Let's just kill the old people and let the youngsters figure it out. Okay, so somebody else was raising a hand, and I just.
Oh, that was me. No, you said the next person that raises their hand gets an award. So I just thought I'd get an award.
Oh, getting award, not an award. Okay. Sorry. Yeah. Okay, Josh, you wanted to say something. Okay, good. So
yeah, I don't necessarily think we should strive for longevity in human life, but there are situations where, like, for instance, should companies live forever? Maybe they shouldn't. Maybe there should be a process where a company gets turned off so that monopolies don't form.
I don't think you have to worry about that. The expected lifetime of a company was like 50 years, so it's already in the system. But maybe
I'd like to say something about that at some point.
Yeah, maybe 50 years is too early. Maybe it has to be like 200-300 years. I don't know, but definitely there has to be some kind of.
But for human life, obviously, it seems the complexity of managing, how long you should live creates more of a problem than just letting it happen naturally. So I think that's kind of a justification for why, yeah, we'd all like to live forever.
So let me just defend why it makes sense for people to live longer. And it may be very subjective defense is, for example, to learn physics and to start to doing research in physics, it takes many years. It's like you cannot do anything until your age of 30. You have to learn all those quantum mechanics, classical mechanics, general relativity, and a bunch of mathematics. And only when you turn 40, you're like, okay, finally I know a little bit. I can start producing.
So maybe it could be like medicine. So like only physicists and brain surgeons and these types of people could get the stuff.
Right. Okay. So it takes a long time of training, and so if you just only live for 40 years, or 50 years. Anand, go ahead. You raised your hand. Okay. We cannot hear you.
Can you hear me now?
Yeah, I can hear you now. Yes.
Awesome. Yes, I'm a neurologist, so I have some interest in the same topics that you guys are interested in. I missed part of the conversation before. I'm sorry. So just wanted to add a few things here, which may be of relevance to all or some of the things that you're talking about. One was actually from the prior meeting, which was about what is life and all that. So one of the things I think you guys did not talk about is maybe you can understand what is life by understanding what is death, which is something I deal with very frequently because we are supposed to call in to do like a legal brain death examination, which determines when a patient has died. And so the important thing you realize there is that death is not just a legal fiction. When somebody dies, their organs actually start deteriorating and wasting away. So there's an actual physical thing called death, which of course we have a legal relationship to as well. And I think that actually ties into, Vitaly, what you were saying the other day about life being some sort of things coming together to a higher level of organization, that kind of joining together. It seems when you look at it from the other perspective of when does life end, that does your postulate actually seems to hold true, meaning that when that questionable death happens and life leaves, all of those atoms and molecules and tissues and all that which were working together into one synchronous unit, when the moment of death happens, even though for the most part, like, if the brain has died, the rest of the body is technically still alive, but for some reason over the next few days to weeks, everything starts deteriorating and breaking down. So that's one. Moving on to the
let me just comment quickly that actually Victor did say that, not me today. I'm of course pointing to this all the time, but it is Victor who said this time that whatever is useful at one level may not be useful in another way around. And so what you just said, like, death, it seems like a tragedy for that single person or nearby family, but maybe this is the way for it to be for the biosphere, right? So on those scales that we are talking about now, Anand, I don't want to just throw all the questions right away, because you have great ideas. But we will also have philosophy topic next. So if you want to, maybe we'll discuss more of that stuff at that point. Also, I'd like to advertise this big question Google Doc where we should just all dump our questions, and then I'll order it in some way and we'll discuss it. Okay.
Excellent. Excellent. Thank you.
Yes, thank you. Okay, so let me just read the next question that goes here. How can we develop better diagnostic tools to detect diseases earlier and more accurate? Okay, so now the question is okay, we got the diseases, but how we can earlier on say that happened. So any thoughts, any ideas? Because I don't want always to be the one who starts.
Why we speak about diseases and therapy? It seems to me it's more productive speak about development and betterning. This is engineering perspective. This is not some kind of remedy.
We can ask both questions, right? So you can ask how we can prevent the diseases, how we can better train
even not prevent, but this is a paradigm like in psychology. There is this some kind of norm, and after this have not norm, we have a therapy, and after this is norm.
Yeah, I mean, look, I mean, medicine is a huge subject.
This
right?
is only one of view, and there is another view. We have some kind of state, and we can develop this state, not a norm, but a state that we can develop, and we will be have continuous delivery, continuous development, all this software engineering thing. We have an organism, and we have continuous development of it.
Yeah, well, development is there anyways. I think what you're saying, can we enhance the development, help the organisms to become a better learner and be more, resistant to different diseases? I think that's what you're saying.
Yeah, and this is development for organism.
That is a little bit different
approach. Better learner. This is not therapy.
No, not therapy. No. I understand.
Of disease.
Yeah.
This is
development. But I think it's a different question. I mean, still, like COVID, right? So, as an example, we want to be able to earlier detect it. Some other diseases, the earlier you can detect the disease, maybe it's easier for you to fight it. And the question is, how can we develop such tools? I think all of those questions are important, but just let's go one at a time. Revel, you wanted to add something?
Yes, I mean, I'd like to start out with a much broader kind of take on this whole thing, and that is, I'm acquainted with and worked a little bit with a Native American psychologist. She's a Harvard trained Native American psychologist, and she used to ask her students during the lecture. She said, I will give an automatic A to anyone in the class who can identify the Western system of wellness. What is it? What does it consist of? And what's the answer? Well, there is no Western system of illness. So in the Western world, we respond to disease, illnesses, accidents, all these kinds of things. But the point of what her point was is that from the Native American standpoint, the system of wellness is 24 hours a day. And then you wonder why the culture.
Okay, that is also in agreement with what Anatoly was saying. But I see Katya raising her hand, and we'll let her speak, of course.
Yeah, I wanted to add that I think one thing that is still missing in this consideration about the diseases and in classification that you gave the first point is immune system. When you talk about the cause of disease coming from outside, the important thing is how the immune system reacts. Also with COVID, it's the question of how good is your organism in processing some information that is coming from outside.
Yeah. So Katya, this is a great point, but I think this is really telling us whether your organism is good in adjusting to different environments. This is like, you change the environments, you sprinkle in some new bacteria, and then you know exactly how to deal with this bacteria. You know exactly what to do. You've developed it, and it is, of course, this is a mechanism that is separate on itself, right? The immune defense system, but it is still it is still your reaction to the outside perturbation that comes to you. So it is still this mechanism is useful for this first type of diseases. Okay, I don't think it is useful for the second and the third type of diseases that you described.
Why not?
Because the second type of diseases is when your cell starts failing, right?
Yes,
so,
it means that your immune system is not doing well. It cannot process well the in some inner processes, some metabolic processes, and it loses the integrity.
Okay, good. All right, so then maybe you're right. Maybe this a more generic defense system that can apply to at least first two types of diseases. What about the third one? Can you have a defense system from overfeeding? I mean, why not? Right? That's. I mean, maybe we're ready.
I don't know. I don't have. I cannot say I have a good understanding of this overfeeding, how it is related to aging. I'm not sure I understand it completely, but
not ability to adjust. Talking about aging, non-ability to adjust for changing environment, right? Like let's put it in general.
Yes, but a minute ago we talked about that ability to adjust is connected to immune system functionality.
That's right. So then the third one is no. Yeah, I understand. So this defense mechanism of immune system is the third type of. If you don't have it, this is the third type of disease. This is the disease that is not enabling you to adjust to the changing environment. That's what I was going to say. Yet it is true that it can trigger the other two. Yes, can be the other two. If you are not able to adjust to changing environment, you'll get punished from the first two types of disease. Yes.
Yeah.
But I don't know. It's just an addition. I don't know to what extent it is important.
I think it's an algorithm. I think it's an algorithm.
Yeah. I think if we talk about prevention of diseases and some health system, the model of some health system how we can manage this, the immune system is the most important point we should consider. That's my.
I agree. Yes, absolutely.
And why you speak about immune system on one level? Because in Levin work about non-mental brain, he described with co-authors immune system and
what is non-mental brain?
Non-mental brain.
What does it mean? Non-mental. What does it mean?
And this is a title of a paper. And this means that brain and immune system they have similar construction. There are several types of cells, and there are communication between cells, and there are some kind of reaction, and they simply working on different levels. On a local level, in Russian, воспаление. Inflammation, and this is immune system, and it work with complex computation, none less than brain computation, to define how to have this inflammation and in what degree, in what kind of agent, and they have a memory and all the same things that a brain. Brain, this is run or bite reaction. And this is the same thing the guard of a border. And we have an organism, and we have bacterial level guard of a border, and all the organism scale guard of a border. Simply two brains or two immune systems. And it seems to me it is a general principle. After this, we have Ministry of Defense, and this is another level of brain that
I'll give you a word in a second. Let me just in a second. Anatoly, but I think we already agreed that the same phenomena would happen on all levels, right?
Yeah, and different.
And every single phenomenon we discuss
construction, but the phenomena the same.
Huh?
Different type of construction.
Oh yeah, absolutely.
System constructionally is not the same that
yeah. So we'll use
brain.
different words for it. We'll have different implementation of the words. But this is just an algorithm that had been discovered on all those levels, on every level, right?
Function, algorithm type.
Yeah, exactly. Yeah, and so
algorithms different, but API is the same.
Yeah, it's again. I mean, in terms of the renormalization group, we have in physics the idea that you will have exactly the same general principle action. Yet, all the coupling constant may change if you go from level to level. And the same thing happens. You know, the general principle will become the same, but it will go.
And this is on the many level. It will be
so
dependent on many
this
levels.
Just deserves on itself a separate discussion, a different discussion, because once you learn something on one level, you should learn it also on the other level and map it. And that's this is mapping through different levels deserves a separate discussion on itself. But now let's just concentrate on one level, and I think Anand has raised his hand. Go ahead, Anand.
Hey, I think for me, at least as a doctor, the one thing I always think about is, when you look at a car and all the things that can happen to it, it can get aging, it can get like a flat tire, parts can break. You don't necessarily think of it as how can I keep my car healthy? It's more of each one is considered like an independent problem that you need to fix. Like, what you do to keep your engine running is not going to help you prevent you from getting a flat tire. But when we come to a human body, I think intuitively, at least traditional cultures like Native Americans, like where the other person was saying, they have this belief that there's something called promoting the health of the entity, which is an all-purpose tool which helps prevent all kinds of diseases. And I think that's an interesting point. Perhaps it has to do with like the ability of the human organism, for example, to self-regulate and get back to a state of whatever, like an equilibrium or something. And so that immune system is definitely one important component, but that's only one component, as in dealing with bacteria and even with cancer. But at the same time, as doctors, we also deal with high blood pressure and diabetes, which don't really have an immune component, but they're also examples of maybe auto-regulatory mechanisms being overwhelmed by repeated insults over time. Again, all of that happens with aging as well. Similarly, things like mental illness. Again, for some reason, there has been some little thing which kind of moves the system away from a certain equilibrium, which is healthy, towards maybe like schizophrenia or bipolar disorder. So I think maybe, at least from my perspective, if we're looking at like a uni-purpose health maintenance tool, which kind of serves as a one-stop shop for explaining all of disease and even all of aging, maybe we should be looking at what is it that helps a healthy young organism or a healthy young brain maintain itself in a very tight, stable equilibrium. And then that kind of, for some reason, gets weaker and weaker as we grow older and we get exposed to. That's probably why also when you say like a lot of calorie intake and carbohydrate intake is correlated with aging. And, dietary carbohydrate restriction, calorie restriction, it's one of those things which has been shown to reverse or even prevent aging in all kinds of organisms. So I think there's something there, somebody like you with like a lot more understanding of systems may be able to come up with a better explanation.
The other thing that keeps you younger supposedly are extreme temperature variations. If you expose yourself to like very negative cold for short periods of time or great hotness, this kind of kickstarts your genetics back into, keeping you younger. But then who wants to do that?
Well, okay, so because those shocks, they trigger the system to increase their biological temperature, what I call biological temperature. And then again, this increasing of temperature gets you out of the overfitted place where it was a very good loss function. You've been very well trained to be in this environment, and all of a sudden you get the shock, and then you said, well, maybe I have to relearn certain things, and that's kind of an important. And that was my claim, right? So that the aging is related to overfitting, and to fight overfitting, you have to increase the temperature, but you have to assist the body or the cell, whoever is aging, to do that, to make that step to increasing the temperature. Alex, you've been raising your hand now. Okay, go ahead.
Yeah, thank you. So just want to at some point go back in that discussion and branch it to other things, because guys, there's no human body. I'm really sorry to say that. So there is a cloud of something, okay? Human body and what they call microbiome, and microbiome actually holds this human body, keeps it alive because it needs it. Because units of life, there are many, many, many more units of life than in human body. Look at Vitaly. Look at him. Do you see him? No. You see just visible part, cloud, and it's fucking changed really fast. It's not
Alex,
human.
please, no, don't use the language, please. Not.
Okay, sure. So, and it's like not like okay, human is not here. It's changing very fast, So, and it's not human who keeps this system alive. So, and it's like another branch, not here, probably.
Yeah. Thank you. Katya, go ahead. You raised your hand.
I wanted to add another point about aging. I don't know if it is about overfitting. Can we somehow relate this or not? But also from psychosomatic point of view, immune system functioning depends a lot on, we can say that it is how good we can handle various information in wide term from outside, including stress and so on. So, generally, we are not handling it perfectly. And so we have some error accumulation in this process. So when you are young, you have some amount of resource. And with time, you exhausting it, and error accumulates, more stress, more ability to handle, and so it influences the physical structures. This is aging, and at some point you can't handle it anymore.
Yeah, so I think it's not contradictory to what I was saying. So you're saying that an ability to do error correction. An ability to do error correction is related to aging. Of course, that's exactly also fitting. So error correction is ability for you to quickly adjust to the new type of environment, like for any changes, and those can be on large scales and on small scales, right? So when you're young, you can stand up quickly and without experiencing any pain, and that kind of doesn't, because you can adjust your trainable parameters in that way very fast. When you're older, you can no longer do that, but you are doing something else much better. You are maybe very good in sitting, or maybe very good in reading, but not so good in doing other things. So I think that an ability to error correct and quickly adjust to the environment is.
It's not exactly about error correction. It's just a bit another thing. I mean, error accumulation. I mean that we don't handle stress completely, and it has accumulative effect.
Well, stress is a great thing. I mean, stress. I think stress is
consequences. If we don't react perfectly, we have some effects on our tissues, and
but
so
that's
on.
true for younger people as well, right? So if they don't react to the rock that flies their way properly and they don't catch it, they die.
Yes, they just accumulated the volume of accumulated bad consequences is less in young people.
Why? Why is
It's
that?
not because it
I mean,
over time.
you're in the same environment. You are two learning systems. You are in the same environment, and yet you react differently on those things, right? And in one
Because
case,
it's accumulate over time.
what happens over time?
Accumulation.
Accumulation of what? But that's what the question. Like, what is it that being
unhandled consequences of some stress situation, imperfect reactions.
Yeah, and that, you're stuck in the wrong minima. That's what I'm saying. You become stuck in the wrong minima, and that's kind of this. And the right solution out of this is just to increase your temperature and start, exercising more and doing all those things that bring you back to where.
Yeah, I'm not saying it is contradictory. I'm just trying
no,
to.
But you're absolutely right. There's very different aspects of aging and other diseases, and we should not just look at and say, well, here's one thing. There are many different aspects. Revel, you wanted to say something?
Well, there's a couple of things I wanted to say. There's this tendency that you hear in society. It's just like, well, I was an athlete when I was younger, but I kept going and going and going. If you keep in your shape and all that, you don't necessarily have to be all weak and lame when you're 50 or 60 and all that. And I think this is a bit of a misnomer in our society. And then people get programmed to believe this, and they just give up and start eating donuts or what have you.
That's my point. That's exactly. You should not do that. And then it's never too late to actually increase your biological temperature and then go back to being young. It's how you feel, right? Alex, you want to say something, but please promise not to use the language that is not
okay. Sure. So sorry about that. So
ladies here. Okay.
Yeah. Sorry. So I just want to maybe put some information to make our homework better, because so there are many humans. They don't have age. I mean, they're getting more mature, but it's not like they're getting old. Tatvali Baba, Prahlad, many cases, and they're studied like military science and civilian science. So why don't we talk about them? I mean, it's like real case of humans, how it should be, and they are dying in a very nice way, So,
no, I mean, we will have such discussions. I mean, this is a long project of all those group meetings and experimental results from the aging research. I don't know. We will discuss it. Why is this organism aging faster? Why is this one aging slower? Any other comments? Go ahead.
I was just going to say, you can go downtown now in my city, and there's a cryo booth. And you go stand in there, pay $25, and it goes down to negative 150 for 60 seconds, and there you go. So it's easy.
Yeah, I mean, and that's why when Katya said stress is great. Any stress is great. Just you have to learn how to handle it, and that's and so stress and temperature fine, emotional stress fine. Just handle it properly, and then it'll be fine. Okay, guys, we're not going to get to philosophy today, I guess. If we keep doing diseases, and we didn't cover half of the diseases, aging questions, but let me move on and discuss at least a couple of questions from the philosophical implication. Now, so the one thing that the one question that was raised, what are the ethical and religious implications of every living thing on Earth being connected, right? So now we kind of discussed it when we said that there is like other levels, and so something that's good on one level may not be good on the other level. But when you make your decisions, right, when you take a choice of doing something and not doing something else, what are the implications? Do you have to?
Well, before you even get going, before you could talk about maybe these implications, you might have to have the general public might have to be convinced by science that this is actually true and not just new age hype.
Oh no, forget about others. No, forget about others. I think you as a person, right? So you have your own. I mean, at some point we discussed, we're all philosophers. Right? We all have our model of the universe we live in, and we all have to make decisions. And then now here we go. You have that knowledge that perhaps well connected, and perhaps it's not just you who are trying to optimize, and it's not just your cells. There are levels below your level. There are levels above your level. When you make decisions, when you make choices, Do I have to reconsider it? I mean, do I have to be more like left-wing or right-wing?
Okay, I got one more. If I'm saying too much, just let me know. But I came up with this unit of interactional consciousness. Like I'm walking down the hallway and I get it, and I meet the delivery guy. I'm like, "Hi, how you doing?" And he's like, "You having a good day?" "I'm having a good day." "Yeah." We go up the elevator and then leave. And I thought, well, there's one interactional unit of positive consciousness, like a unit of something, maybe.
There you go. No, I think that's great. That's a good example of how you would want to behave, right?
But what I liked about it, Vitaly, is that there was no negative anything. It was a very pure experience. I didn't know them, So if we can do, this is maybe like an example that could serve as a reference.
Mm-hmm. Right.
Yeah.
No, I mean, that's a good example. Now, let me just explain this example in terms of the learning theory. If we are all nodes in this social network, right? What Revel just did with the pizza guy is establish some kind of connection, right? Now, it might have been useful only for a short period of time, but maybe not. Maybe that brought some positive energy.
But it may go on. Yeah.
But the information, one bit of information, one bit at a time, right? One bit of contact in time. And so, although the more contacts you make, the better it is, right? The more useful as a node in this network you are. So I think you'll be right. But let me ask you this trolley question now. This philosophical puzzle when you have to make a decision. The trolley goes down the rails, and you have to make a decision whether to, kill one person or kill 100 people. What would be your choice? So if you don't do nothing, then only 100 people dies. If you do something, If you do something, then one person dies. So what would be your?
Are you talking about when AI is starting to control our traffic systems and railroads and things?
No, your decision, right? There is this trolley called puzzle, whatever they call it, paradox, right? Whatever the philosopher came up with. So you have two choices. You either don't do anything and the one person dies, or you pull a trigger, you don't do anything and one person dies, 100 people die, and then if you do something, then only one person die. So what would be your choice?
Might depend on the person.
Well, anyways, I mean, this is again, from the point of view of learning theory, it's better fewer people to die, unless that one person is really smart and is important for the overall growth of the society. Okay, let me not stay too much on that question. Anybody else wants to add about any ethical or religious application of the living things being connected?
That question would be better handled by a machine then that did not have a conscience.
Well, the machine would definitely choose to kill one person.
Yeah, that's what I'm talking about. But but then if the machine made the decision, that wouldn't have the sense of guilt over having to choose between the lesser of two evils.
Yeah, but it is you who are making the decision. You are right there. It's okay. Katya, you have
I don't have anything to say about this these ethic tricks. I can't imagine anyone can answer, but just in generally, ethics is primary the point of my interest, and I'm very curious what kind of answer we can extract from what kind of answers the theory can suggest us. But I think that I cannot, I don't know if we can say something about this. It's a lot, mostly about the conflicts between the levels. If we are talking about relations between people, it's one thing. If we are talking about the relations between of people to animals, it's another thing. I think there is terrible things are happening. Maybe we should stop it, but then at what level should we stop it? Because maybe cancer cells want to live, and viruses and so on. So this kind of, I wonder if we can have some scaleless model of judging, of of having some ethical judgments. And also, if we say that the first question that you skipped was what is the meaning and purpose of life and how should we live our lives? And the answer is probably learning. But again, how can we know we are learning? How can we define knowledge? Because I think, is it right that the how to say everyday social routine meaning of knowledge is wouldn't be a good landmark here, because we are getting education, but not in all cases it is good learning. So what could be the landmark? How we can measure that? If we have to say that what we are doing is good if it is learning, but what is the criteria? Is it learning or something else? This kind of things. So I wonder very much what kind of implications of all this we can have to apply to some psychological or social context.
Okay, so Kati, good point. Let me. You always many questions. So one question about conflict between levels. Vertical conflict versus horizontal conflict, right? So it is true that when we are resolving horizontal conflict, we in both directions we can be more selfish, and we are more of thinking about the bigger good for the biosphere, let's say, or for the universe, right? And then it would give you different answers to that question when you are trying to model it. So I think this should be modeled, right? We should model. What is this greater good? What is this greater loss function that now, in my opinion, this would be is going on, right? So if we make a decision, going on, right? So for the civilization to go on and develop further and further. So if we
civilization and what is the relation between civilization and biosphere?
By civilization I mean the whole biosphere. I don't care about it's the whole biosphere, everything we see around us. For this whole mess that we are in, I would be making the decision if I have done calculated, like put on the computer with model possible outcomes. If I see that the output is such that that this biosphere will develop further and we'll learn more and more about the environment, right? So now we have a standard model. We understand how gravity works, but if we can push the knowledge further. Understand psychology, understand how social systems work, how medicine, and all those things. Then we're making progress. And this is one of the points we have these meetings, right? To actually create some kind of group where we can push this knowledge further. And that's why. So this is kind of along the hopes that I have for this. Now that's answering that question. So it needs to be modeled, and it's a difficult question to ask whether it's horizontal or vertical. Now, the second meaning, the point of life, and how do we know, like, what knowledge? I agree that learning should be the purpose, at least in this theory. The more you learn, the better it is. But how do you evaluate knowledge? And also, I'll add to this: how do you evaluate intelligence? So, knowledge is just collection of data, of information. The books we wrote. I don't know. You can all put them in some digital carriers, right, or whatever. But then there is also intelligence, which is how fast you can learn new things, right? So the learning efficiency. So in the language of machine learning, there are two numbers that tell you how a given neural network works: is how fast it learns, like learning efficiency, and then the other one, what is the loss value in asymptotic time, how good it will learn. And so those are two different things, and really you would want to optimize for both. And if I have to choose between the two, then, well, it's always two, right? But then if I have to choose between the two, then I'll say, okay, what is the time scale for which I'm optimizing? Do I want to have learned the most in a year, or do I want to learn the most in 100 years or in 1,000,000 years? And then the answer will be different. And then you will be, in one case, supporting more of the learning efficiency, and the other one is supporting more of asymptotic loss. So those are the questions you'll be discussing. But I think still with a good modeling of how the biosphere, the society evolves, we can make those choices. The one thing for sure, none of this is, well, again, this gets to politics, and we'll be discussing politics at some time later. But for the society to function properly, we should have exactly the same hierarchy structure where there's scale invariant structure, just like we have in a biological system. So there should not be like, one node which is very important and everybody's connected to this. It should be all kind of plasticity, plus criticality. I said like in the very beginning, right? Learning material should have criticality, so that all skills are present in the system, and the same to have plasticity, so all the connections can be readjusted, and all that is not present in social systems. For now, Rebel, you're raising your hand. Go ahead.
Well, so in your artificial neural computer, you're looking for a more socially equal distribution of neurons, so to speak, than you find in society.
Wait. So society is a horrible example for the learner. So we haven't made this transition. So we as a society are not functioning yet in the optimal way. So all the hierarchy and the connections, social connections that we have are wrong. Okay. Now, for example, the Facebook connections network, if Facebook gives us the weight matrix of their connection, we can run spectral analysis and we will see it's wrong. Why it is wrong? Because it was optimized for something else. It was optimized for their profit, right? So, and that's not what we want to optimize. We don't want to optimize Facebook's profit. We want to create a social network which optimizes for gaining the knowledge, right? And or learning efficiency. And so that's not a good example. But when I was saying, so social system is definitely bad, but with the learning material, yes, it should, from just theory, it tells you what kind of things it should have, whether the material is social. It should have some kind of scale invariance in it, and it should have plasticity. So you can, you should have freedom and more flexibility of meeting other people and connecting with them when it's needed, and also disconnecting with those that are useless. So you have to have plasticity, and then you should also have this propagation. You should be able to connect to other people more freely rather than so with this respect, we are not optimal systems at all, and there is an explanation for that. We haven't made that phase transition. So internet was a good first step for connecting people, but the structure of this network is horrible for now. So
Structure of the whole internet, or specifically what?
What is it?
Specifically, what structure are you talking about that you don't like?
Oh, so right now the structure of connection in the social networks is wrong. We use all some kind of social network to connect with each other, right? Like Facebook or Twitter,
Right.
and then there's a network of connections, and so that doesn't have the right structure. For one problem is this social bubble you're living in, right?
Let's say you were design one social media structure that was not based on profit. Do you think more people would find that attractive?
Of course. Then you would not be meeting people who only like support your view, but you would be meeting, for example, I would be meeting people who have critical thinking, right? That would be my objective, because I want to find ideas, even if those ideas disagree with mine, but I see there's a critical thinking behind it, right? Then there is some logic behind it. Then I want to establish that connection, right? Now, if I see other people who are offensive, then I don't want to establish this connection. And that's why, like in the very beginning, I said there are two conditions that we have to satisfy. We have to respect each other, and we have to be thinking critically. And those are important things for establishing good connections. That would be useful.
I think the only problem with creating a social media network that required critical thinking is a lot of people don't really know what it is.
No, but not for, that's for me. That's for my connection would be important. Somebody else, I don't know, they would like to have a connection according to their hobbies. Nothing wrong with that, but even that not happening, right? So because maybe science is my hobby, right? So for the other person, it may be sports. Well, sports is also my hobby. If the connection would be establishing, that would make this structure more of a learnable system, I think. Now we are moving to the direction that I was not planning to discuss today, but nevertheless it was interesting. Let me just close with one last question, and then maybe it's like open-ended question, but then we'll meet next time. Can existence be thought of as just more stable state of non-existence. I don't really know what that means exactly, but my interpretation was, can you think about learning system, more learning system to be a more stable state than non-learning? And I would say yes, or more conscious system like we defined last time. And I would say yes, because a more conscious, because the system that is not a good learner yet will go there, will start learning, and because those are the laws of the dynamics. But the opposite will not happen. And so I would say that yes, a learning system is the more stable one than non-learning one, or existing system is more stable than non-existing. But again, those are hard philosophical questions, and I don't know.
It's hard to define what is non-existent. Give me an example of something that's non-existent.
Yeah, that's what I'm saying. So kind of, I don't know, some fundamental particle. I'm just trying to guess what the person who asked this question meant, because again, remember all those questions I didn't ask, somebody posted them, but that kind of, I thought it means learning versus no learning, or being efficient learner versus being non-efficient learner. I think there is a general tendency of systems to evolve towards more efficient learners. So that's kind of general tendency. It's like stupid subsystems do not survive. And we discussed it, remember, right? Survival versus learning, right? So that was kind of one of the discussions we had before. Any other thoughts, ideas? We already passed 1 hour.
I still, sorry, but I'm not sure I understood the answer about what about the conflicts between the levels, and what kind of what does it give us from the point
How to
of view
behave, right? How to
resolving ethical questions? How we can,
no, let me just, I think modeling, Katya, modeling, right? So you model all this hierarchy of systems, then you write down your loss function, which is, we all agree, maybe learning, the environment and, understanding the universe better and better. And then you tell, people this was unethical, and this was ethical, because this was unethical because, you will kill all, by doing this, you will kill all the birds, and the birds are important in this overall biosphere, but but you should not, so something like this, a good model, and then a model which will tell you what is more or less ethical, maybe a scale, and this is completely unethical, this is more or less ethical, and things like that.
So this is the theoretical answer. How
Right.
What do you think
How
about
in practice it will work?
Of implementing it in practice?
No, that's actually not theoretical. Theoretical is there is a loss function which we have to optimize, but the practical is you model it, you put it on the computer,
yeah, I mean, did you do that? Or
no,
now or when we can have such kind of
okay, good. So if we manage to make this phase transition and this group becomes kind of the super intelligence that is capable of actually with all our skills that is capable of framing the questions and answers, then we can model it, then we can put it on the computer, we'll have input from all directions, because like I'm a physicist, I would model it one way, but I wouldn't be taking into account the knowledge that psychologists have, for example, right? So because I know that, but if I know have their information, they can put it in the model, and then it will be some kind of, think about app that will make suggestions on different ethical questions. But it will not be app run by big tech, but app run by the decentralized app where everybody is contributing, and maybe objective may evolve with time and change. I'm speculating for now, but in principle that can be done, and then each person would have a system that would help assist him in making decisions, and it will not be just black and white, right? It will be there'll be a lot of gray areas. So yeah, I mean it's not very ethical, but it's kind of okay, so go for it, and things like that. So I don't think it will just label it as black and white, and there's yeah. Anyways, I don't have all the
Sounds
answers.
great.
I wish I did, right? Yeah, but that's why we need the help from everyone. Other questions, comments before I close today's session?
I have a few words, gentlemen.
Oh, go ahead, Alex. Right, you have a
Yeah.
first.
Still
Okay.
me.
Yeah, go ahead.
Sorry, I was late because I had a very busy day. East Germany. Listen, I missed most of the discussion, but what I wanted to say is about specifically about this idea of this guy making the decision. We constantly forget one very, very important thing. That is that all European and old and new systems of morale, of ethic, of relationship between people have always been based, that's extremely important to remember, on one very important barrier, which was always there. The relationship between two people are always very important, and they can be based on mutual benefits and so on and so forth, and agreements or disagreements for that matter. But very important variable was always there, that was God.
Mhm.
What you now create is a system where the role of God is played by the machine. You know, you make an input into the machine, and then you get some sort of you have a third person, so to speak. You have a third something, which will ultimately carry the weight of a decision, which will ultimately advise you of what is best for you and for the person who is opposite.
That's not what I had in mind. That's not what I had in mind. Let me like.
Let me
Yeah, go ahead.
You had a long discussion today, and I'm so sorry because I had no time.
Go ahead. Sorry. Yeah, go ahead.
Which is great. But let's keep this in mind, that when we discuss relationship between two people, we always, in terms of classical ethics, we always keep in mind, and we should always remember, that all those treatises, all those relationships, all those conventions were developed with an idea of Christian message at the center of it all. So there was a set, not only the set of principles regulating relationship between people, but also always present this irrational element. The benefit of people in getting engaged in relationship with each other very clear. But very often, and this is Dostoevsky, by the way, you should know, very often people behave against their benefit. Very often they follow their inner self. They do things which are completely
irrational.
Unpredictable. Exactly. They indulge in that. And this is exactly when we say, aha, here is the moment of great revelation. Like Saul, you remember, he goes to persecute Jesus. Everything is quite normal. I mean, that's his benefit. He is performing his duty. Suddenly, he stops, turns around, and goes exactly the opposite direction.
Right.
What happened? God happened. So when we are discussing now a completely different thing, which excludes this barrier.
Right.
You entitle the computer, you can entitle artificial intelligence to be this variable. And you basically push this other variable, the big, into the fringes of your thought, of your calculus, of your society. That is very, I'm not saying it's dangerous, I'm not saying it's bad, it's just the new reality. We need to understand that the supercomputer and artificial intelligence will be necessarily placed at the pinnacle of our decision-making process when it comes to the ethical questions and decisions, where the God, I quote unquote, was before. So therefore, I feel that every time we run this story about the guy who has to make a decision and kill 1 or 5, we deliberately, this is called искушение, temptation, we deliberately designed this story, this episode, this situation, deliberately designed to exclude the third.
Yeah. So let me defend God, and let me defend the approach. Now, I hear you. First of all, it's very useful comment, absolutely useful, and it is right. And we haven't digged into ethical issues far enough to know all that. So your input is very much appreciated. But the system that I envision is to have a system of people connected within this network, the social system, the superintelligence, and then the decision would not be made by the AI, but would be made by the people that are just nodes in this AI system. So if I ask AI today, now should I kill one person or 100 person, they may give me a different answer from tomorrow. Should I kill one person or 100 person, depending on the setup. So I'm not replacing the God with the AI. I'm replacing the decision making, ethical decision making, with the network which has right spectral properties of connected people, and all the contribution from God comes from all those nodes of people who believe in God, because they have their views, and that all those views would be represented in this super intelligent decision making machine. I don't know if it makes sense, but that
one thing: who decides what is good and what is bad?
Yeah,
Tell
so
me.
it is this system, right? The system of people and nodes connected within this network. And again, today it will be one thing which is good or bad. Tomorrow it will be other which is good or bad. But once we model how the system evolves, the decision comes down to optimizing the loss. So people decide what the loss function is, like vote on it. I don't know. The loss function is to learn the environment. For the civilization to work, and then that's it. And then you have this combined system. It is smarter than any part of that system, much smarter.
This has nothing to do with intellect, my dear. This is the crux of the problem. This has nothing to do with intellect. It has nothing to do with who smarter is and who isn't. It is everything to do what is good and what is bad. And this is defined. It's completely irrational thing.
How would you define good and bad? Say Shakespeare's good quotes, nothing is good or bad, but thinking makes it so.
Yeah.
I mean, you could define good and bad in terms of pain and pleasure. That would probably be the most accurate. If you want something to say it's bad, it's painful.
Well, but that's a loss function defined on a single organism. I'm saying that the correct loss function is not defined for a single organism, but defined for entire biosphere, let's say, if not for the universe. Okay, and then maybe something that is painful might still be good. Okay, it's not good from your point of view, and that's why you suffer, but it's good from the point of view of this overall loss function that you are trying to optimize. Now, but I guess, yeah, so nothing, well, I mean, I don't know, any other opinions on this?
Yeah, I'm sorry, I understand, I realize it's too long, but still I have to say something about this.
Go ahead.
3 points. First, I think that it's my aspiration would be that not we need some decision-making tool or machine, but what we need is a better model of ethics that could somehow, some ideas, how we can, some language, how we can address these issues that we just cannot resolve in.
But that's exactly the model of ethics.
Yes,
this is
what
exactly
I
the
mean.
structure of the network and the loss function is exactly the model of ethics. Yeah.
This is the answer. I'm answering mostly to Alex at this point. So and this is the wait. Please wait. Let me finish. And these kind of things which I mentioned about before about conflicts between related to the conflicts between the level. They are just not addressed in Christian ethics. It's not in the field of consideration. So we just don't have any answers. So we need them. This is the first thing. Then I think there are two ways of, maybe not two, but different approaches to, how can I say, cognitions, способы познания.
Yes,
so,
sure.
So there are different ways of cognition, and one is rational, scientific, or maybe not only scientific is rational, but rational in general. This is one thing, and there is another thing like direct knowledge. we can talk about direct knowledge from the point of view of some spiritual practices or development or spiritual system. I think there is no denial of one by another. Maybe we need both, but we are here, we are discussing the rational approach. And I think it makes enormous sense because it's better for communication in modern up-to-date world, because if we cannot sit here and discuss direct knowledge, because if I know something directly, I don't need to discuss it with you. So this is just another thing. And the third point is that, yes, it's good to talk about God, but we should remember how many evils have been made in the name of God. So this judgment that I'm making it because of God, it's very questionable.
It's really hard. It's really hard to define what is. I mean, even Vitaly, we're talking about pain. Even pain might be helpful sometimes for growth, right? I mean,
oh, absolutely. No pain, no gain, right? That's what they say.
We're not talking about God. We're talking about fundamental idea of irrationality. And my question is to gentlemen several, and especially to Katya, how do you model irrational? How do you model irrationality? Please.
I can help, Katya.
Please.
Irrationality is modeled as entropy, and rationality, growth of the entropy production, and rationality is modeled as entropy decay. And so we have learning systems are trying to fight their irrationality by creating correlations, finding correlations, and understanding how the universe around us works. Now, if there's something we do not understand, we say, well, we confirm that model with the maximum entropy principle, and that's okay. And that's how we all. That's the only thing we can do.
But we are bounded in our understanding of what is happening around. So again, probably something which we see as irrational is just the goal of some higher level learning system, and we cannot computationally understand what is going on, and what we see as irrational. No need to fight it in some cases. That's really an answer to your question from the first meeting about what is an entropy. Yes, there are there's understanding of entropy as just our limit in understanding computationally what is going around, and so there is no natural law of growing entropy. If you just remain on your level, some things will essentially look like entropy for you, and there's no guarantee that they are really something which is fighting. You have to fight or follow.
No, I agree with you. So entropy is something that you don't know. This is how you model something that you don't know until you know it. And once you know something about it, you adjust your probability distribution and you model it differently. And that's what scientists do. We all model probability distributions. Okay, we model probability distributions of how what's more or less probable. And the point is just to not make any assumptions about the things we don't know. The problem with modeling becomes if we start making assumptions about the things you don't know, or trying to find correlations in the data when there are no correlations, like cherry picking. You pick certain data. That's the problem. And then the scientific method tells us don't do that. Learn everything you can about the universe and then model it. That's what we do. And we can do this modeling for the physical system, for biological.
But there is no guarantee that you can do it for ethical level. For what is not probably what it ought to be.
Oh yeah, good. Unless you have a framework. That's what Katya was saying, and I confirmed. Unless you have a model. So if you have a model of the biosphere with a loss function with connection, then you can say, okay, well, this is beneficial, this is not beneficial. Now somebody else says, screw biosphere. I just want to create myself to be in the good in a good shape. And then the loss function for that person would be different, and objectives of that person would be different, and the ethics for that person would be different.
But as a scientist, you have to be always be ready to adjust your model, to adjust your weights. And
absolutely. So once I know there is a person who is like selfish, I will readjust my weights and will make different decisions because I know there is like such and such node.
Yes, but it makes scientific ethics of a scientist something quite different from what we read about ethics from ethical studies, really.
But that's the point. We are trying to make ethics a scientific branch where we actually modeled how the system evolves. It's a complex system, yes, but it has its objective, and so we model it, and now we make scientific, maybe we should call it a scientific ethics, right? The one that is based on actual modeling, not just on hypotheses that cannot be checked.
Sorry, I'm not sure I understand this notion of ethics for some selfish person. What does it mean?
The person who ignores the other horizontal and vertical conflicts. So we have a person. It's not objective ethics, right? So it's a person just created for himself a bubble where he decided to filter all of the information from the outside of that bubble. All that information is actually entropy for him. It's unknown, right? He doesn't care about you. He doesn't care about anybody else.
But why should we help him?
No, but we should model him. No. But we model him as such person who makes the decisions which are based on his, closed bubble, and so we will make the right ethical decisions regardless of the fact that some of the, it's okay. So now it comes to the question of parasites, right? Should you fight the parasites or should you just let them live? And sometimes it isn't worth fighting them. There will be parasites on biological levels. There'll be parasites in the level of societies. If they're really bad and they can cause you to die as a society, then yeah, you should fight
I think
them.
there may be ways to get the parasites out in many different levels.
Well, but there are many of them. I mean, okay, so I'm just telling you about biology. What we know about biology is if they are not harmful to you, they drain your resources, right? But if they're not killing you, then it may be to fight them and to kill them, you have to use more resources. And so you have to find a balance. Does it worth fighting them, or you just leave them alone? And what happens in biology is sometimes they are parasites, they're wasting your resources, you don't fight them, but eventually you trick them, you will find them a way to be useful. Right? So they were parasites, they were very bad for your system, but then you didn't fight them, you let them go, they evolved.
Next day they are mitochondria in your cell.
Right, and then you say, all right, well, actually, here is a task for you, small task, do it. And he's okay, I know how to do it, I'll do it. And that can be also for people like parasites. They may look useless first, but then you train them to do something else, and then they become useful for society. So it's not necessarily killing the parasites, but sometimes tricking them. Being smarter than a parasite may be more useful. So. Guys, that was a great discussion, almost 2 hours, and I promised it should be only 1.5. But thank you all, and I hope to see you all next week, and we'll have fun discussion then. Thank you, guys. Bye-bye.
Thank you. Bye.